Tell me when you're starting it.
Okay, guys, so we're going to start with the ambiguous case, which is when we have two sides and an angle, but the angle is not sandwiched in between the two sides. So that's what the SSA means. So there's three cases for this. The first case is the first case is that no triangle exists. The second case is one triangle exists. And the third case, which is the hardest case, is two triangles exist. So on the third case, we're actually going to be doing not twice the work, but more work. So if you look on page 564, there are some conditions in some general terms, but I think what's easier is if we just look at an example of each. So this shows it. So example 3 is one where there's a single solution case. So that's kind of like what we've been doing. There's been one solution. So for the triangle in figure 8.4, which I'm going to draw out, and then it gives these conditions right here, find the remaining side and angles. So here's this triangle. Again, never drawn to scale because we all know how good I am at drawing things. Here's side C. It says side A is 22 inches, and it says side B is 12 inches. It gives angle A at 42 degrees. Okay, so it says find the remaining side and angles. We're gonna start with finding, angle B. And remember I said at the very beginning, we want to have our unknown on the top. So we're gonna actually use the reciprocal form here. We want sine B over side B, which is 12, equals sine A, which is sine of 42 degrees, over 22. So we're going to multiply both sides by 12. Multiply both sides by 12. So I'd get sine B equals 12 times sine 42 degrees over 22. Now, I would just enter this all into your calculator at once. You could do this piece, hit enter, round it, and then take B equals the inverse sine of whatever that decimal is. But either way, you get B is about 21.41 degrees. Okay? Then to get angle C, we take 180 degrees minus 21.41 plus 42 degrees. And we get that angle C is 116.59 degrees. So it makes sense that angle B would be smaller than angle C because side A was bigger than side B. So we should get that side C is the biggest out of all of the sides because angle C was the biggest out of all of the angles. So let's set up to get side C. So C over sine 116.59 degrees equals 22 over sine 42 degrees So C is equal to sine 116.59 times 22 over sine 42 degrees. Again, I enter the fraction first, hit enter, then enter this on my calculator, and we get that side C is 29.40 inches. All right, try to pause me and try the next one. But I'm gonna jump right in. Okay, so given angle A, side A, and side B, we're gonna find the remaining stuff. So let me just draw this out really quick. Here we go. If this is A, this is C, this is B. A is 31 degrees. Side A is 12. Side B is 5. And there's side C. It's gonna work almost exactly the same way as the last one. So I'm gonna go a bit faster. We're gonna do sine B over 5 equals sine 31 degrees, which is sine A, over A, which is 12. So sine B equals 5 times sine 31 degrees over 12. So B is equal to 12.39 degrees. Now to get angle C, we would just subtract that one plus 31 degrees from 180. So we get 136.61 degrees. Oops. Now, we want to get side C. So we do C over sine 136.61 degrees equals side A over sine 31 degrees. So we get C equals sine 136.61 degrees. I need to erase. Times 12 over sine 31 degrees. Put this all in your calculator, and you should get that C is equal to about 16. Okay, next is the no solution case. So show that there is no triangle for which A is 15, B is 25, and A is 85 degrees. So it gives us both of our A pieces and one of our B piece. So our only option here is to set up to solve for sine B. So sine B over B equals sine A over A. So let's just try that. So sine B equals 25 times sine 85 degrees over 15. Now, sine 85 degrees over 15 times 25 is equal to about 1.6603. Now, 1.6603 is greater than 1. Now, if you guys remember, sine and cosine never venture outside of 1 or -1. So this right here shows that there is no solution because this cannot be equal to sine B. Okay? So we're going to do it again here. We're going to show this again. So sine B over 14 is equal to sine of 60 degrees over 4. This would be sine B equals 14 times the sine of 60 degrees over 4. We'll enter that into your calculator. 14 times the sine of 60 degrees divided by 4. That's about 3.03, which is greater than 1 for sure. So that's for sure no solution. Sine B cannot be equal to 3.03. So the no solution cases are probably the easiest. Now, the two solution cases are where it gets a little bit harder. Find two triangles for which A equals 12 meters, B equals 31 meters, and A equals 20.5 meters. So we need angle B, angle C, and side C. So let's always start with angle B because they gave us side A and side B. If they would have given us side C, we would have found angle C first. But since they gave us side C, since they gave us side B, we're finding angle B first. So we're going to start with sine B over side B, which is 31, equals sine 20.5 over 12. This gives us sine B equals 31 times the sine of 20.5 degrees over 12. Okay, now 31 times the sine of 20.5 over 12 is equal to 0.9047 about. There are two angles where sine is equal to that. One in the first quadrant, one in the second quadrant. If you type it into your calculator and take B equals inverse sine of 0.9047, you're going to get the first quadrant angle, which is 64.8 degrees. Now, if we want the second quadrant angle, we have to also subtract that from 180. So our other option is 115.2 degrees. So these are our two options. So we've got two options for B. That means we've got two options for C, angle C, and that means we've got two options for side C, okay? So there's a big mess here. That's why the two solution thing is a bigger deal. So for angle C, and now with angle C, when we're solving, obviously we're gonna default to angle A, but when we're solving for side C and we use law of sines, we're always gonna use angle A and not the angle B. Okay, so for angle C, our first one, it's equal to 180 minus 64.8 degrees plus 20.5 degrees. Oh my goodness, I keep doing that, guys. I'm so sorry. So our first angle C is equal to 94.7 degrees. Okay, now with that angle C, let's find, that's our first angle C. So with that angle C, let's find that option for side C. So we would have C over sine of 94.7 degrees equals side A, which is 12, over sine of 20.5 degrees. So C equals sine 94.7 degrees times 12 over sine of 20.5 degrees. So C, this first C, would be 34.15 meters. Now for our second angle C, which I'm going to do down here, it would be 180 minus 115.2 plus 20.5. Which would be 44.3 degrees. Okay, so that's our second angle C. So C's two possible triangles. We have two possible angle B's, two possible angle C's, and this is going to give us two possible side C's. So if I have C, side C, over sine 44.3 degrees equals, excuse me, 12 over sine 20.5 degrees. I would solve this the same as I solved up here, and you would get C equals 23.93 meters. So that would be your second side C. So in both these triangles, your angle A and your side A are the exact same length, but your B's and your C's are different lengths. And then what I actually would like to do is I am going to save this example for when we Google chat on Friday, because I would like to do one in person. So those of you who show up to the Google meetings, we're going to do this one together on Friday. Okay? So, yeah. So that's it for this video for today. I'll have another one. The